Section 7.5, Dividing Polynomials. So you can see in this section we have some more rules that we have to become familiar with. The first rule is called the quotient rule. The quotient rule tells us that when we are dividing exponential expressions with the same non-zero base, we subtract the exponent in the denominator from the exponent in the numerator. Okay, so if you remember back to our product rule, when we multiplied bases, we added our powers. Well, now, if we're dividing bases, the same bases, we actually subtract our powers. Alright, so let's look at an example. Example 1, let's illustrate why this works. So we have x to the 5th over x cubed. And I want to know, why does that come out to be x squared? So if I have x to the 5th in my numerator, I have 5 x's being multiplied together in my numerator. Now, if I have x cubed in my denominator, that's x times x times x. Well, if there's an x in the numerator and an x in the denominator, they divide out just to be 1. So that's 1 over 1. That divides out to be 1 over 1. And so does that one. Now I'm out of x's in my denominator, so I can't divide any more out. So my result is the x times x left in the numerator, which basically gives me x squared over 1, since all those divided out to be 1. Which is just x squared. Remember, when I do an x divided by an x, it leaves behind a 1. So these are all like 1s. 1 times 1 times 1 just gives me 1. So you can see that the rule here works. According to the rule, we would do 5 minus 3 and get a power of 2. But you really want to get an understanding of what's happening behind the rule. So you're basically canceling out or dividing out x's until you have no more to divide out. Alright, let's look at number 2. So the base is 5. So this becomes 5 to the power of 12 minus 4, which is 5 to the 8th. Over here our base is x. So this becomes x to the power of 16 minus 3. Which would be x to the 13th power. Right. Over here we have x's and y's. So you can think of this separately if you want. Do the x's first and do the y's second. So for the x's, I'm going to get x to the power of 7 minus 1, because remember, that's x to the first power. And then for the y's, I'm going to get y to the power of 4 minus 3. So this becomes x to the 6th times y to the first power, or we can just say x to the 6th times y. And I'm done there. I can't do anything else because one's an x and one's a y. So there's no more rules I can apply. My final answer is just x to the 6th power times y. Let's go to number 5. According to this, I should do 4 minus 4, x to the power of 4 minus 4, which is going to give me x to the power of 0. That's kind of different. We haven't really seen that before. So we need to know what that means, x to the power of 0. Well, what does that mean? Well, let's go back and look at this right here. If I have x to the 4th power in the numerator, and I also have x to the 4th power in the denominator, think about what's going to happen there. All of these are going to divide out and leave behind 1. divided by x is just 1. So in my numerator, I have 1 times 1 times 1 times 1. And in my denominator, 1 times 1 times 1 times 1, this just equals 1. So this tells me something about x to the 0 power and about the number 1. Well, let's see what that tells me. Let's look on our next page. Aha, we have a new rule. The 0 exponent rule. As long as my base does not equal 0, then anything raised to the 0 power equals 1. Go ahead, test it out. Do 3 to the 0 power on your calculator. You're going to get 1. If you're not sure how to type that in, you probably use that caret button. Of course, it depends on what kind of calculator you have. But anything raised to the 0 power is just 1, because that means you have the same exponent on top as you do on the bottom, and then what we saw here will happen. Everything will divide out. Alright, so example of the 0 exponent rule. Y does x to the 0 power equal 1? Well, again, let's look at the same example we looked at last time. X to the power of 4 over x to the power of 4 gives me x to the power of 0 if I use the quotient rule. Or think about it this way. If you have a fraction and you have the same exact thing on the top as you do on the bottom, well, that just equals 1. And if it's variables that are confusing you, let's go over here for a second. Let's say we had 2 to the 4th power divided by 2 to the 4th power. Well, that would be 16 over 16, which would still equal to be 1. So if your bases are the same, this is just going to divide out to be 1, which is the same as x to the 0. So here our base is negative 10. So we have a base being raised to the negative, or I'm sorry, we have a base being raised to the 0 power. All that equals is 1. Now let's look at number 3. Number 3 looks very similar to number 2, except number 3 does not have the parentheses. The difference in number 3 between number 2 is that in number 2 the base was negative 10. In number 3 our base is just 10. The only thing being raised to the 0 power is 10. The negative sign is not part of the base. This is the same as having a negative 1 times 10 to the 0 power. Well, 10 to the 0 power is 1, so this answer is actually negative 1. So you got to be careful when there's parentheses and when there's not. Same thing in number 4. The only thing being raised to the 0 power is the x. Okay, the 5 is not part of the base. So x to the 0 power is 1. So this is like 5 times 1, which is just 5. Now let's look at number 5. Well, now the whole base, or the base, is all of the argument in the parentheses. The base is 5x. So since this is all in parentheses, I can say that that answer is 1. Let's look at number 6. Okay, again, if you want to split this up, you can. Do the numbers in one fraction, so 5/10. Do the x's in another fraction, and do the y's in another fraction. So 5/10 is 1/2. Remember, this is going to be the quotient rule. There's really a 1 right there. So this is going to be x to the power of 2 minus 1. Now with the y's, I could think of it like this, 7 minus 0, which is just going to be 7. Or just think here, this denominator is equal to 1. So y to the 7th over 1 is just y to the 7th. Okay, so I get 1/2 times x to the 1st power times y to the 7th power. So I have 1/2 xy to the 7th, or you can write your answer like that, xy to the 7th over 2. Either one of those is acceptable. Alright. So that was our second rule. We have a third rule called quotients to powers. And this one says when a quotient is raised to a power, what you're supposed to do is raise the numerator to the power and raise the denominator to the same power. So basically, quotients to powers, inside my parenthesis here I have a quotient, a over b, and I'm raising that whole quotient to the power of n. So both the numerator and the denominator get the power of n. So for instance, in number 1, if I want to simplify the quotient 2/3 raised to the second power, that means my numerator gets the power as well as my denominator. So this equals 4/9. Or you could think about it this way. If you're squaring something, you're multiplying it by itself. Well, 2 times 2 is 4, 3 times 3 is 9. Either way, get the same answer. Alright, let's look at number 2. Okay, everything is going to get the power of 3. So my numerator gets the power of 3, and my denominator gets raised to the power of 3. Now notice in my numerator here, now I have another rule. I have products to powers rule. So now the -5 gets cubed as well as the x to the 4th power. And then the denominator also does. So remember what we said in class. It's kind of like the power of 3 goes to both of those. So -5 gets raised to the 3rd power as well as x to the 4th. So -5 to the 3rd power is -125. This becomes x to the 12th. Remember my rule, powers to powers, I multiply 4 times 3. And then in my denominator, 2 to the 3rd power is 8. So -125 x to the 12th power divided by 8. Okay, let's look at number 3, same thing. My numerator is raised to the 4th power as well as my denominator. So 2 gets raised to the 4th power as well as a to the 10th gets raised to the 4th power. Now that I've got everything with the 4th power, I can simplify. 2 to the 4th power is 16. 10 times 4 is 40, so that becomes a to the power of 40. And 3 times 4 is 12. So 16, a to the 40th, all divided by b to the 12th. And let's look at number 4. Alright, now my denominator is being squared, but not the numerator. So I have to work with the denominator in this case first. So my numerator is going to stay the same. In my denominator, this becomes 4 squared, x squared, y to the 4th, and z squared. Notice right here, we became y to the 4th power because of 2 times 2. And the rest of these are just exponents of 1. So 2 times 1 gives us exponent of 2. 2 times 1 gives us an exponent of 2. 2 times 2 gave us an exponent of 4, and 2 times 1 gave us an exponent of 2. Alright, let's simplify it a little bit more here. I'm going to leave the numerator as is for now. So 2x to the 6th, y to the 5th, and in my denominator I get 16 x squared, y to the 4th, z squared. Okay, now let's break this up. 2 over 16, I'm going to do that first. That's 1/8. Then my x's is going to be 6 minus 2. My y's is going to be 5 minus 4. And you'll notice I don't see a z. Well, really what there is there's a z there, but it's a z to the 0 power. And the reason why I don't see it is because z to the 0 power is just 1. So I could really say it's there, but really what's going to happen is my z to the 2nd power is just going to stay as is in my denominator. But let's go ahead and write it, because this is going to lead us to a rule that we're going to learn later on about negative exponents. So we'll just kind of preview it right now. Alright, so this gives me x to the 4th, y to the 1st, and now this 0 minus 2, that 0 minus 2 gives me z to the negative 2nd power. And like I said, that's totally new. We haven't learned that yet. That's coming later. I'm just kind of previewing it for you. So here's what's going to happen. This right here, if we go back and look up here, that z to the 2nd power is just going to stay where it is, because there was really nothing to subtract it from other than z to the 0. So I'm going to rewrite this whole thing. My x to the 4th power and my y, those are up in my numerator. Now 1/8 means 8 is part of the denominator, and so is the z squared. So this problem, like I said, kind of introduced us to a new rule here, which we're going to learn later. A rule for what happens when we have a negative exponent. So I just kind of wanted to introduce you to that now so you get a little preview. Alright, one more. Dividing a polynomial by a monomial. To divide a polynomial by a monomial, divide each term of the polynomial by the monomial. Now that sounds kind of wordy, but it's really pretty basic. So let's look at number 1. I have this whole entire polynomial all divided by 3x squared. So notice how it says divide each term of the polynomial by the monomial. So what that means is I'm going to do here is I'm going to divide every term by 3x squared. Okay, so let's do these one at a time here. So let's look at this one first. Negative 15 over 3 is negative 5. Now let's try to do a couple steps together. 9 minus 2, that's going to give me x to the 7th, plus, let's do this one now, 6 divided by 3 is 2, and now x to the 5th over x squared, that's 5 minus 2, that gives me 3, and let's do this last one. 9 divided by 3 is 3, and x to the 3rd power over x squared, that's 3 minus 2, which is just 1, which is just x to the 1st power. Now, if you want to check your answer, since we divided, we can check by multiplying. So to check my answer, I'm going to take my divisor, which was the 3x squared, and I'm going to multiply it by the answer that I got. And if everything multiplies out, then I know I did it right. So I'm going to distribute here. So 3 times negative 5 is negative 15. And with the x's, I'm going to add the powers. So 2 plus 7 gives me 9. Here, 3 times 2 is 6. Again, I'm going to add the powers. So 2 plus 3 gives me 5. And now here, 3 times 3 is 9. This is first power. And 2 plus 1 gives me x. Cubed. Sorry. 2 plus 1 gives me x cubed. So what I want to do is just verify that it gives me what I started with originally. And it sure does. So this is just my check. This is my answer. This was just checking to make sure that I got the right answer. one more. Okay, so same thing, I'm going to divide all of these by 6x. So 24 divided by 6 gives me 4. And that's going to become x to the 8th power. Remember, if I'm dividing by 6x, that's x to the first power. So 9 minus 1, that's where I get the 8th power. 12 divided by 6, that's going to give me 2. And then 4 minus 1 is going to give me x cubed. Now here, notice 10 doesn't divide by 6. 10 6, all we can do is make that 5/3.